So what we have learned that a number is either rational or irrational. So the rational and the irrational number together, they are grouped as real numbers. Because why are they real numbers? Because they do exist. As I'm using the word real, in your higher classes you will also learn about numbers which are not real. But that's a later part of the story. Every real number is represented by a unique point on the number line. Yes, even the irrational numbers can be represented on a number line, and we have techniques for doing that. Every point on the number line represents a unique real number. The real number is the real number line. So the number line which will be discussing now is the real number line, because all the real values of the number can be represented on that line. We have a number line on which we represent the numbers which are not real or the complex numbers, but we'll be studying for the time being the real numbers. Finding, as I told you, that on a number line we can represent infinite number of rational numbers. If I ask you a question that how many rational numbers can you fit between two rational numbers 1 and 2? If I give you two rational numbers 1 and 2, and if I ask you a question, how many rational numbers can you fit on the number line, if it's a number line? If on a number line, if I give you two numbers 1 and 2, and I ask you what will come between 1 and 2, think. Yes, it may be little difficult for you to think what would come between 1 and 2, because you are not thinking about rational numbers, you are just talking about, or you may be thinking about natural numbers. But why do we forget that between 1 and 2 we may have decimal values like 1.2, 1.3, 1.99, and even if I divide it further into very minor segments, I can have 1.001 as well. So there are infinite values. There are infinite numbers, or infinite, I would say, rational numbers that can be fitted between two rational numbers. So that would be our next topic. Let us see how do we fit the infinite rational numbers between any two given rational numbers. Suppose I have two rational numbers. I've shown you with example of 1 and 2. But if we generalize it, how do we generalize it? If I have two rational numbers R and S, then and how many rational numbers will be there in between? Infinite. Then between R and S, if I have to put one particular value, suppose my R is 3 and S is 4. Then between 3 and 4 on a number line will come the mid value of 3 and 4. The mid value of 3 and 4, and it's very simple to calculate. The mid value of any number is given by the sum of the numbers divided by 2. So the mid value of 3 and 4 will be 7 divided by 2 equal to 3.5. So obviously, if I have to fit one rational number between two given rational numbers, it will be the mean value. Mean value is the average value that is obtained by adding the two numbers and dividing it by 2. But what if I have to fit more than one rational number between two given rational numbers? Like here, they've asked you that find three rational numbers between 2 and 3. But you may ask me that I've just told you how to fit one rational number by finding the mean value. If I had to find one mean value between 2 and 3, I would add 2 and 3 and divide it by 2. But what if I have to find more than one value? Let us do it with the help of a number line first, and then I'll explain you the technique. This is 2 and 3. And the mid value we can find out, we know we can find out one mid value. that is adding the 2 and dividing it by 2, and between 2 and 3 I know the mid value will be 2.5, but this is just one value. Two more values can be inserted here and here. How? By considering this also as a part of the number line now. Previously I had two values 2 and 3, now I have yet another value 2.5. So if I have to insert two more values, I will take the mid value of 2 and 2.5 and one mid value of 3 and 2.5. By using the same technique, previously my R was 2 and S was 3, from where I got the third rational number 2.5. Now my R is 2 and S is 2.5. So the next rational number will be adding these two and dividing it by 2. So 2 plus 2.5 will give me 4.5. 4.5 divided by 2 will give you 2.25. Similarly, 5.5 divided by 2. 2.5 plus 3 will give you 5.5, and 5.5 divided by 2 will give you 2.75. Thus we can have three rational numbers which can be fitted in a number line between two given rational numbers. In the similar way, we can have infinite. Between these two values also I can have two more values. Between these two I can have two more values. So there are infinitely many rational numbers between 2 and 3, or between 3 and 4, or between given any two rational numbers. Those two rational numbers need not be a natural number as shown here. They can be a decimal number also. For example, if I take 1.5 and 1.6, between 1.5 and 1.6 also I can fit infinitely many rational numbers. For example, if I take decimal number 1.5 and 1.6, then also in between these I can fit as many rational numbers as I want. The same technique will be followed. Method 1 is the method that I have just told you, that divide by 2, the sum of the two numbers to be divided by 2. The sum of the extreme values divided by 2 will give you the mid value. So as we can see in the example, if I have to fit a rational number between two rational numbers 2 and 3, add the 2, divide by 2, and we can get as many rational numbers as I want. Method 2 is less tedious than method 1 and it's quite simple. What is method 2? If I go by the same example, that I have to find rational numbers between two given rational numbers 2 and 3, I have to write the rational numbers in the form of numerator upon denominator. So 2 can be conveniently written as 2 upon 1 and 3 can be written as 3 upon 1. What next? Next is counting how many numbers do I want. So here suppose I have to insert three rational numbers between 2 and 3. So what would I do? I would add 1 to the total number of rational numbers which I require. If I require 3 rational numbers between 2 and 3, then I add 1 to 3 and make it 4. But what to do with this 4? I have to take this 4 as the denominator of the given numbers. I have to convert the denominators of the given number to 4. So according to the examples which is shown here, 2 was previously written as 2 upon 1. 2 was written as 2 upon 1. Now if I have to convert the denominator of 2 to 4 using the law of equivalence of fractions, I have to multiply the numerator and denominator of 2 by 4. To make the denominator 4, I cannot simply only multiply the denominator by 4, I have to multiply the numerator also with 4 and it will give us 8 upon 4. Similarly, 3 can be written as 12 upon 4. Now let us draw a number line. And this is my 2, this is my 3. I have 2 is equivalent to, I have converted it to 8 upon 4 and 3 has been converted to 12 upon 4. Why this 4? Again I am reminding you, again recalling that we make the denominator equal to 1 more than the number of rational numbers required to be fitted in between the two given numbers. So, I have to insert numbers between 8 upon 4 and 12 upon 4. Let's think that way, that we do not have to insert numbers between 2 and 3. We have to insert it between 8 upon 4 and 12 upon 4. Now, focus on the numerator 8 and 12. Between 8 and 12, I have to mark all the numbers between 8 and 12 on this number line. So, after 8, I will have 9 upon 4, then I will have 10 upon 4, then I will have 11 upon 4. So, we have got all these 3 numbers very easily. So, the numbers between 2 and 3, the 3 rational numbers between 2 and 3 are my 9 upon 4, 10 upon 4 and 11 upon 4. These are the 3 numbers between 2 and 3. So, basically what is the idea? The idea is just to convert the denominator. And how do we convert the denominator? We convert the denominator by making the denominator 1 more than the required number of rational numbers. So, if 3 rational numbers have to be inserted, we make the denominator 4. Had 4 rational numbers been inserted, we should have made the denominator 5 and so on. So, if n rational numbers have to be inserted, if we were supposed to insert n rational numbers, then the denominator would have been n plus 1.